Hello everyone, welcome to my channel. Today we are going to study integration by partial fraction. This topic is very important according to board point of view, okay, and it is coming for higher marks in your exams, okay. So let's just study how to integrate your function by using partial fraction, okay. So basically there are three types in the partial fraction. There is type 1. Let's just study the type 1. In the type 1, see any of his we have total three types: type 1, type 2, type 3. But the main thing is to remember that the degree of numerator should always be less than the degree of denominator, okay. So in any of the types you will always see that your degree of numerator is less than the degree of denominator. Now let me tell you the degree. What is the degree of any polynomial? The highest power of that polynomial is known as the degree, okay. Now let's just come to the type 1. So according to the type 1, if you see, we have px plus q, okay, and in the denominator we have the two brackets, that is x minus a, x minus b. So this can be expressed in the form of a upon x minus a plus b upon x minus b. A and b are some constants, we need to find the value of that constants, okay, right. Now also the second form here is px square plus qx plus r. Here we have three brackets. If you see, these three brackets are the distant brackets, totally different from each other, okay. So here it can be written as a upon x minus a, b upon x minus b, and c upon x minus c. Also here we have to find the values of a, b and c, write it over there, and then we have to integrate it, okay. Now let's just move on to the type 2. In the type 2, we have the numerator as px plus q, and in the denominator we have x minus a the whole square. Now this means that we have x minus a multiplied by x minus a. So we have the two terms of x minus a. We say that the denominator is repeated, okay. So here x minus a is repeated two times. This can be expressed in the form of a upon x minus a and b upon x minus a the whole square. So in case you come across where the denominator is repeated, so you can express like this, okay. Now the second form, if you see px square plus qx plus r, here if you see x minus a is repeated and x minus b is totally different. So first we will do the repeated form, that is a upon x minus a and b upon x minus a the whole square, and for the x minus b we will write c upon x minus b. Just understand the pattern, okay. Let's move on to the type 3. In the type 3, if you see px square plus qx plus r, we have the quadratic term in the numerator, but in the denominator if you see, we already have a quadratic term, but with that we also have this linear term, that is x minus a. So in that case we have to write a upon this linear term, that is x minus a, plus in the numerator we shall write bx plus c upon your quadratic term, that is x square plus bx plus c, okay. So this is a three types of the problem that you will be coming across the partial fraction, okay. So we will solve 2 to 3 problems based on this, all types, covering all the types, so that you understand, and also how to find the values of a, b and c, okay. Now let me just take the first example here. I is equal to integration x square plus 2 the whole upon x minus 1, then x plus 2, and then we have x plus 3. If you see, in the numerator we have x square plus 2, and in the denominator we have three distant brackets. All three are different from each other, so it is type 1 problem, okay. So for the type 1 problem we have to take the numerator, okay. We have to take the numerator upon this whole term, that is denominator x minus 1, x plus 2, x plus 3 can be written as a upon the first bracket, b upon the second bracket, and c upon the third bracket. Please remember, you can switch a, b and c. It doesn't need to be that first bracket should be given under a, the second one should be given under b. The sequence doesn't matter. Okay, you can switch it. Okay, now after doing this we will do the LCM. So just think that we are multiplying both sides by these three brackets. Okay, so that will give you x square plus 2 is equal to a times x plus 2 x plus 3 plus b times x minus 1 x plus 3 plus c times x minus 1 and x plus 2. Okay, I can write the reason here so that you don't forget. I'll write multiplying both sides by x minus 1 x plus 2 and x plus 3. Okay, this is your reason. You shall remember, but you don't need to write it in your piece of paper. Okay, now I'll take this as equation number 1. We have to use it later on. Now after doing this, we need to find the values of a, b and c. Now how to calculate the values of a and b and c? So first we will take this first term, that is a upon x minus 1. Okay, so we have x minus 1. What we will do, we'll take x minus 1 equal to 0. So x gives you the value of 1, right? So substitute, take this as equation number 2. So substitute or put x is equal to 1 in equation 2. Okay, so that will give you 1 square plus 2 is equal to a. This will be 1 plus 2, this will be 1 plus 3. But if you just notice here, I'll tell you, we are substituting x is equal to 1. So in that case, this term will become 0 and this term will become 0, right? 1 minus 1 becomes 0, 1 minus 1 becomes 0. So both of this term is 0, and 0 multiplied by b, 0 multiplied by c will give you 0. So you don't need to write that b and c. Okay, you can just skip this part. Okay, so this will give you 3 and this will give you 3 times 4. So a will be equal to 3 upon 3 multiplied by 4, which is 1 upon 4. This is the value of a that we got. Okay, hope you understood this part. Now just let move on to the next substitution, because we are still remaining with b and c. I'll do here also. Now we'll substitute, put x is equal to, so below the b part we have x plus 2. So when you equate x plus 2 is equal to 0, we come across x is equal to minus 2, right? So we'll substitute x is equal to minus 2 in equation 2. Okay, now we will substitute x is equal to minus 2 in the equation number 2. So that will give you minus 2 square plus 2 is equal to, now in this case what we see here is we have this x plus 2. So here it will be 0 and here it will be 0. So 0 multiplied by a and 0 multiplied by c will give you 0. So the only thing that is remaining is the part b. So you are getting the value of only b here. Okay, so I'll just rub this out. So that will be equal to b minus 2 minus 1 and minus 2 plus 3. This will be equal to minus 3 and this is 1 and this is 4 plus 2. This will be 6 is equal to b times of minus 3. So b is equal to 6 upon minus 3, which is minus 2. So we got the value of b, which is minus 2. Okay, right. Now we'll move on to the third part, finding the value of c. So for finding the value of c, again you have to look what is below the c. In below the c we have x plus 3. So when you equate x plus 3 is equal to 0, you get the value of x is equal to minus 3. So let's just substitute x is equal to minus 3 in equation 1 and see what we get. Minus 3 square plus 2 is equal to a and b will become 0. So we are only left with the c term. Okay, so that will give you c times minus 4 times minus 1. Okay, so this will give you 11 and this will be 4 times of c. So c will be equal to 11 upon 4. Okay, so we have got the value of c also. Now from equation 1. Okay, so from equation 1 what do we have? That is x square plus 2 upon x minus 1, x plus 2 and x plus 3 is equal to, so the value of a will substitute 1 upon 4 x minus 1, then value of b which is minus 2 upon x plus 2, and the value of c which is 11 upon 4 upon x plus 3. So let's just integrate the whole thing here. I'll just put the substitution, take 1 by 4 here, we'll write x minus 1, then minus 2, 1 upon x plus 2, then 11 upon 4, 1 upon x plus 3 dx. Let's just integrate individually. 1 by 4 integration 1 upon x minus 1 dx minus 2 integration 1 upon x plus 2 dx plus 11 upon 4 integration 1 upon x plus 3 dx. Okay, so here if you just remember the formula upon, that is integration of 1 upon x dx, which was log of mod x. So the same thing can be applied for the linear functions. If you have a linear function, let's say if you have x plus or minus a, so in that case also you can apply the same thing. Instead of x it will be x plus or minus a, because it is a linear function, so we can apply. Similarly here also this will be log of mod x minus 1 minus 2 log of mod x plus 2 and 11 upon 4 log mod x plus 3 plus c. Okay, this is a formula part, I'll keep it separate. So here the value of I we got, that is 1 by 4 log x minus 1 minus 2 log of x plus 2 plus 11 by 4 log of x plus 3 plus constant. Okay, so this was it. Now we will do another type of problem which is based on the another type of the partial fraction. So let's just move on to the next part where we are taking a second sum, that is I is equal to integration 1 upon x cube minus 1 dx. Okay, now here what we have, 1 upon x cube minus 1 dx. So instead of here you can see we don't have the brackets in the denominator, but what we have is the cubic polynomial, that is x cube minus 1. So how do we arrive at the 2 brackets or 3 brackets, whatever do we have? So for that what we need to apply the formula. Instead of 1 we will write as 1 cube and we will apply a cube minus b cube formula. Okay, I'll write it here, the formula of a cube minus b cube. A cube minus b cube is nothing but a minus b a square plus ab plus b square. This is the formula of a cube minus b cube. So we can apply the same formula here, taking a as x and 1 as b. Okay, so this can be written as integration 1 upon x minus 1 x square plus x plus 1 dx. Okay, we have applied the same formula. Now let's just consider this whole thing as a upon x minus 1. Now if you just see, we have the two brackets. First bracket is a linear term, but the second bracket is a quadratic term. Okay, so this is a third type of the partial fraction. Okay, so if you remember, a upon the linear equation that we used to write, and the second part would be bx plus c together upon your quadratic equation, that is x square plus x plus 1. This is your equation 1. Now if you take the LCM or multiply both sides by this two terms, you will get 1 is equal to a times x square plus x plus 1 multiplied by this whole thing by x minus 1. This is equation number 2. Okay, now let's just decide how to find the value of x. Okay, so below a what we have is x minus 1 equated to 0, so that will give you x is equal to 1. So put x is equal to 1 in equation 2. So this will give you 1 is equal to a 1 square plus 1 plus 1. Now this term will become 0, but still let's just substitute. So b times of 1 plus c, and this will be 1 minus 1. Okay, now if you can see, this 1 minus 1 becomes 0, and this whole thing will be multiplied with b plus c, that whole thing will become 0. So instead I'll write 0 here, and this will be 3 times of a. So a we got as 1 upon 3. Okay, hope you understood the value of a. Let's just move on to the another part, that is we have to find the value of b and c also, but we don't have the linear term to equate it to 0. So instead of that we will use a random value. Okay, so for the random value, let's just take a simplest value, that is x is equal to 0 in equation 2. Okay, so 1 is equal to a times 0 square plus 0 plus 1 plus b times 0 plus c, and this will be 0 minus 1. Okay, so this will be 1, and this will be multiplied with 1, and here the b times of 0 will become 0, and c multiplied with minus 1. So here it will be a minus c is equal to 1. So overall we get a minus c is equal to 1, but we know the value of a, which is nothing but 1 by 3. So 1 by 3 minus c is equal to 1. C will be equal to 1 by 3 minus 1. Okay, which is nothing but minus 2 by 3. So we have got the value of c, which is minus 2 by 3. Okay, now we have to take the another random value, because still we don't know the value of b. So for that we will take another random value. Let's take x is equal to 2. Okay, I'll write it here. So put x is equal to 2 in equation 2. Okay, so this will be equal to 1 is equal to a 2 square plus 2 plus 1 plus 2b plus c multiplied with 2 minus 1. So 1 is equal to a 2 square is 4, 4 plus 2 6, 6 plus 1 7 plus 2b plus c, and 2 minus 1 will become 1. Now we know the value of a. So this will be value of a is 1 by 3 multiplied with 7. Value of b we still don't know, and the value of c is minus 2 over 3. So this becomes 7 by 3 minus 2 by 3 plus 2b. This will give you what? 5 over 3 plus 2b, and this is equal to 1. So 2b is equal to 1 minus 5 by 3, which is minus 2 by 3. Okay, now this will be divided by 2, that will give you minus 1 by 3. So the value of b here is minus 1 by 3. Okay, hope you understood this of the process of finding the value of a, b and c. Okay, now let's take the equation 1 and write it again. So this will be 1 upon x minus 1 x square plus x plus 1 will be equal to the value of a, which is 1 by 3 upon x minus 1, and the value of b, which is minus 1 by 3x, and value of c is minus 2 by 3, the whole upon x square plus x plus 1. So now we are integrating this whole thing. So integration 1 by 3 1 upon x minus 1. Now taking this minus sign outside as a common, and we'll take 1 by 3 also common. So that will give you x plus 2 upon x square plus x plus 1. Okay, the whole dx. Now we'll integrate individually. So we'll take 1 by 3, and this will be 1 upon x minus 1 dx minus 1 upon 3 integration x plus 2 upon x square plus x plus 1 dx. Now we have to integrate this. Okay, so I'll repeat this part because we don't have to do anything here. What we need to do is here. Okay, so first, if you just take the derivative of the denominator is x square plus x. If you take the derivative, that will give you 2x plus 1. Okay, so for that we need 2x plus 1 in the numerator. So for that, what we can do, we will just do a small change here. We'll multiply 2 in the numerator as well as in the denominator. Okay, so that will give you what? 1 upon 6 integration. This 2 will be multiplied inside, so that will give you 2x plus 4 upon x square plus x plus 1 dx. But what we needed here is only 2x plus 1. So we'll write 2x plus 1 and plus 3. We can separate it, right? X square plus x plus 1 dx. This shall be repeated. Okay. Again this will be repeated, integration x minus 1 dx minus. Now this 1 by 6 will be multiplied to both of these two terms. Okay. This term and this term 3 along with the minus sign. So that will give you minus 1 by 6 integration 2x plus 1 x square plus x plus 1 dx minus 3 over 6 integration 1 upon x square plus x plus 1 dx. Okay, now this will be cancelled by 1 by 2. Okay, so we know the value of first integration, we know the value of second integration. Now what we have to do is to find the value of the third integration. Now third is nothing but 1 upon the quadratic term. So to solve that part, we need to find the third term. Okay, so let's just move on to the next. I is equal to 1 by 3 integration 1 upon x minus 1 dx minus 1 upon 6 2x plus 1 upon x square plus x plus 1 dx minus 1 upon 2, and the third term. So the value of third term will be half into coefficient of x, the whole square. So what we have here, the coefficient of x is 1. So half multiplied by 1 the whole square come out to be 1 by 4. Okay. So here what we'll do, we'll write x square plus x plus 1 by 4 minus 1 by 4 and plus 1 dx. Okay. Again this whole thing will be repeated. I'll write it here in the last part. Now this can be written as in the form of a square. It will be x plus 1 by 2 the whole square, and this will be 4 minus 1, that will give you 3. So 3 over 4 dx. Okay, now this again will be repeated. I'll just write it down in the last step. 1 by 2 integration 1 upon x plus 1 by 2 the whole square, and this can be written as root 3 by 2 the whole square, right? So this becomes 1 upon x square minus a square formula. Okay, So we have to apply that part. Okay, now we know all of this, so I'll just write it down here. I'll just rub this, I'll write it down. 1 upon 3 integration 1 upon x minus 1 dx, 1 upon 6 integration 2x plus 1 x square plus x plus 1 dx. Okay, now we know the value of all three integral. Okay, so let's just apply it here. Okay, and let's see what we get. Okay, so I will be equal to 1 by 3. Now it is a linear term, so 1 upon, consider it as a x. Okay, so that will give you log of x minus 1. Now here, since we have the derivative of the denominator in the numerator, we can write log of denominator, that is x square plus x plus 1 minus 1 by 2, and this is 1 upon x square plus a square formula, which is 1 upon a times tan inverse of x upon a plus c. Okay, this 2 and 2 will get cancelled, so we are left with 1 by 3 log of x minus 1 minus 1 over 6 log of x square plus x plus 1 minus 1 over root 3 tan inverse. Now this can be done by using LCM, that will be 2x plus 1 upon root of 3 plus c. So this is the final answer that we have got. I hope you understood this third type of the partial fraction. So let's just consider one more problem, which is based on the second type of the partial fraction. Okay, so I is equal to integration 3x minus 2 upon x plus 1 to the power 3 and x plus 2 dx. Okay, so instead of power 3 we have power 2, so I'll write it here. I'll just write this again. 3x minus 2 upon x plus 1 to the power 2 and x plus 3 dx. So if you can see in the denominator, we have the two terms, that is x plus 1 the whole square and x plus 3. But instead we have three terms because x plus 1 is repeated. Okay, and we know according to the type, if any term is repeated, how do we have to write it? Okay, so let's just see how do we have to write whether it's your term is repeating. So 3x minus 2 upon x plus 1 the whole square and x plus 3. Okay, so my x plus 1 is repeating two times, so first of all a upon x plus 1, then b upon x plus 1 the whole square, and then you have to take your linear term, which is c upon x plus 3. So whenever it is repeating, first take that term with the power as 1 and then take it with the power 2 and then take the remaining linear term. Now we are multiplying both sides by x plus 1 the whole square with x plus 3. So what we left with 3x minus 2 a times x plus 1 x plus 3 plus b times x plus 3 and c times x plus 1 the whole square. Okay, so here we have this can be considered as 1, this can be considered 2. Now let's find the value of x. Okay, so below a we have x plus 1. Let's just equate x plus 1 equal to 0. That will give you x is equal to minus 1. So we'll take x is equal to minus 1 in equation 2. Okay, so this will be 3 into minus 1 minus 2. Now if you just see here, with the a we have x plus 1, so this term will become 0 when we substitute x is equal to minus 1. Okay, and this term will also become 0 when we substitute x is equal to minus 1. So a and c will be eliminated, what we left with only b. Okay, so I'll just rub this out. So this will be equals to b times minus 1 plus 3. That will give you 2 times of b, and this will be minus 3 minus 2 is minus 5. So b is equal to minus 5 upon 2. Okay, this is the value of b that we get, minus 5 upon 2. Okay, hope you understood this. Let's just move on to the another part. So for finding the another values of x for substitution, if you look around b, below b again we have x plus 1. When we substitute to equate it to 0, so again you get x is equal to minus 1. So if you substitute the same thing again you will get the value of b only. Okay, so rather than doing that, move on to the part c, and c upon x plus 3 we have. So x plus 3 equate to 0, so x is equal to minus 3 we get. So let's just substitute x is equal to minus 3 in equation 2. Okay, so that will give you 3 times of minus 3 minus 2 will be equal to, now if you just look at here, with the a we have x plus 3, so when we substitute x is equal to minus 3, that will become 0. Okay, and also with the b part we have x plus 3, so when you substitute x is equal to minus 3, this also becomes 0. What we left with only c. Okay, so c will be equal to minus 3 plus 1 the whole square. So that will give you minus 2 the whole square, that is 4c, and this will be what, minus 9 minus 2, that will be minus 11. So c will be equal to minus 11 upon 4 we got. So we have got the value of b, we have got the value of c. Now we don't have any values to equate to 0. So for that we'll take a random value. Let's take x is equal to 0 in equation 2. So that will give you 3 times of 0 minus 2 will be equal to, now if you just look at here, with the a we have x plus 1, x plus 3. Okay, so I'll write it here, a times 0 plus 1 and 0 plus 3 plus b times what we have with the b, x plus 3. So that will be 0 plus 3, and what we have with the c, that is x plus 1. So again this will be 0 plus 1 the whole square. So this will be 3a, 3b and c, and this will be minus 2. So when we substitute the value of a and the value of c, we already have, sorry, we have the value of b and c. Okay, so 3a times plus, now what was the value of b that we got, value of b was minus 5 over 2, minus 5 over 2 minus 11 over 5. So that will give you 3a minus 15 by 2 minus 11 by 4 and minus 2. Okay, let's move on. So minus 2 and minus 15, that will become plus, and this will become 11 by 4 is equals to 3a. Okay, now we have to do the LCM. So multiplying in the numerator and the denominator with the factor 4. Okay, so let's see what we get. So this will be multiplied by 2, this will be multiplied by 4, and we will have the common factor as 4 in the denominator. So this will be minus 8 plus 30 plus 11 is equal to 3a. Okay, so when we solve this, let's see what we get. So by doing all of this, what we get here is 30 plus 11. 30 plus 11 gives you 41, and 41 minus 8, that gives you 33 upon 4 is equal to 3a. So dividing both sides by 3, so that will give you 11 by 4 equals to a. That is a equals to 11 by 4. This is the value of a that we get. Okay, so now we'll write I. I is equal to a times, which is 11 by 4 upon x plus 1, and the value of b is minus 5 upon 2 upon x plus 1 the whole square, and the value of c is minus 11 upon 4 upon x plus 3. Okay, integration, and this will be dx. We'll take individually integration. So 1 upon x plus 1 dx minus 5 upon 2 integration 1 upon x plus 1 the whole square minus we'll write dx minus 11 upon 4 integration 1 upon x plus 3 dx. Now we'll apply the integration formula, simple one. 1 upon x, that is a linear term, so that will be a log, and 1 upon x plus 1 the whole square. Now here also we have to conduct, that is 1 upon x square. So we can apply the power series formula. We can apply the power formula, which is nothing but integration x to the power n is x to the power n plus 1 upon n plus 1 plus c. Okay, because it is a linear term, so we can apply, consider it, take as 1, take it as x, and when we take in the denominator, oh sorry, in the numerator, that becomes x to the power minus 2. Okay, I can solve it here, x to the power minus 2. So when we integrate this, that we get x to the power minus 2 plus 1 upon minus 2 plus 1. That gives you x to the power minus 1 upon minus 1. So that is nothing but minus 1 upon x. Okay, so but instead of x we have x plus 1, so that will be my x plus 1 minus 1 upon x plus 1. This is how we can calculate it. So I'll just rub this out. Okay, so we'll write the final answer, that is 11 upon 4 log of x plus 1 minus 5 upon 2 log of, not log, here it will be minus 1 upon x plus 1 and minus 11 by 4 log of x plus 3 plus c. We'll take this log term together. Okay, we'll take 11 by 4 common, so that will give you log x plus 1 minus log x plus 3, and this will become plus 5 by 2 1 upon x plus 1. Minus and minus will become plus. Now here we can apply the log property, log of x plus 1 minus log of x plus 3, that will give you log of x plus 1 upon x plus 3 plus 5 upon 2 times 1 upon x plus 1 plus c. So this is the value of I that we get. Okay, so I have taken problems based on the 3 types of the partial fraction. I hope that you understood this. Also, if you haven't subscribed my channel yet, please do subscribe it and also share it with your friends, and do not forget to practice these problems based on the partial fraction. It comes for your board exam. Okay, it is very important. Okay, thank you so much for watching this video. Have a good day.